Hey everyone, welcome to the introductory R course. As the first part of the series, I'll be covering on how to set up R and RStudio on your systems. So if you can see here on the screen, I've got R showing up on the CRAN website, the R download, and you can just pretty much click the link and download the setup file. For Mac OS, you just have to search for Mac OS on Google and look for the CRAN website. So this is the official repository for R, so you can pretty much download this one, would download the latest version of R for Mac. So along with this, we'll be working with an integrated development environment, and which is RStudio. So RStudio is available on rstudio.com, and there are multiple offerings. So choose the free version. As a prerequisite, you'll have to install R on your system. In this case, it requires R3 and above, so they're anyway downloading R4, so it shouldn't be a problem. So download RStudio for Windows, and this is for the 64-bit version. If you're on a 32-bit system, you can download an older version of RStudio here. So besides this, there's also support for multiple other OS systems. So for Mac OS, you have a download link provided here. For Ubuntu, there's something here, and so on. So you go ahead and install all of the exe files. And in the next one, I'll show you how to use RStudio and all of its features.
As you can see, I've got RStudio installed on my system as well as R. So we have the R version 4.0.2 installed. If you want to check the version of RStudio on the system, you can just use the help tab here, and this is the version that we have. So as you can see, this is where we write the code, and the console is where typically the code outputs are displayed. Data frames, vectors, lists, and all of the data types are stored here in the environment. And you can also see plots, for instance, as an output here. This also has files, which basically shows you the working directory and all of the files inside of the working directory. Packages, so all of the packages that come available with R. So one is the user library, which is packages that you can install. System library is basically packages that come installed with R. So you can check the version you have and also look for updates. So if I click this, I get updates for 3 packages. And I can choose which ones I want to install, and just click install, and it will do that. If you want to import a dataset, you can do that as well. You can use text, SPSS, Excel, Stata, and so on. And if you want to save your project, just click Save As, and you should be able to save it. Hey everyone, welcome back. So in this video, we'll be looking at 3 important things. 1, we'll be learning about working directories and how to modify them. 2, we'll be learning how to import files into R. And finally, we'll be looking at how to install libraries. So one of the best things about R is the fact that there is a strong developer community that continuously works towards providing packages and new libraries that are at the forefront of data science. As a user, you could just go to the CRAN website, pick up these packages and install them and get started. So it's as simple as that. So let's get started. The first step is to create a script file. I've already got one open here, but otherwise you would have to go to File, New File, and select R script. So as a first step, let's find out what working directory we are in currently. So base R has a function called getWD, which is nothing but get working directory. So I'll just run this piece of code, and I get a working directory now. Now, in order to modify the working directory, I just simply have to use setwd, which is short for set working directory. So I'll just copy the same code, and maybe instead of desktop, I can use documents, for instance. So now that we have changed the directory, we can actually check it again. So let me run getwd, and now it should show the path pointing towards documents. Yeah, it does that. So as the next step, we'll look at installing libraries. So R has a very simple way to do this. So you have to remember this piece of code, install.packages. And if you know the name of the package, you could just key it in here. So for instance, I'm installing the DPLYR package, the most useful ones in R currently. So I just have to key in the name of the package and hit Control Enter. And it will automatically fetch it from the CRAN website and also install all of the dependencies that are required. So for instance, if you see here, I chose to install DPLYR, but it would also go about searching for any other dependent packages that need to be installed first. And it will download all of that and then install everything together. That's very convenient, right? And then in order to call it again, you just have to use library function and then search for DPLYR, and then Control Enter should DPLYR. Yeah. So let's try to import a CSV file into R. So base R again has a read.csv function that does exactly that. So let me just key that in, and I'm going to import a file called epl.csv, which is available in the working directory that we mentioned, the documents directory. And I would also mention header equal to true, so it'll declare the first row as a header, and strings as factors equal to false. So what happens is R sometimes assigns character vectors to be factors. We'll discuss more about this in detail in the next set of lectures. But for now, just remember to include strings as factors as false and set header equal to true if the file itself has header in it. You can also assign this to a particular variable and save it in the environment, right? So let me just assign this to a variable called A, and that should save here. So that's it, guys. See you in the next one. Hey everyone. So in this video, we'll be looking at a couple of things. One is how to update libraries once you've installed them already, and two, how to update R and R Studio. So updating libraries is pretty straightforward. You just have to navigate to the packages section here and look for the library that you've installed. So for instance, I can see DPLYR installed and there's a tick next to it and so on. You can just click up the update button and you should see the packages that you've gotten installed already. One is rlang and vctrs. I'm not sure what this is. And we've installed a version here, and the available one is the latest one. So you can just select whichever you want to install and hit install updates. This is one method. Also, you can go to tools and click check for package updates and you should get the same screen. R Studio, that way, is pretty straightforward. You just have to navigate to the help button and click check for updates. So currently we're using the latest version of R Studio, so no updates required for this one. For R, it's a bit tricky. You'll have to download the latest version of R from the CRAN website, but even then it cannot be directly run, so you'll have to uninstall the existing version of R that you have and then install the new version. So that's a bit complicated and may take time, but besides that, everything else is conveniently laid out. And honestly, I would tell you that it's very rare that you might have to actually update R itself. And most of the time, you should be fine with whatever version of R you're using. Hey everyone, welcome to the series on Introduction to R Programming. So in this video, we'll be covering data types and data structures. So R boasts of a wide variety of data types such as numeric, integer, and floating point numbers. Floating point numbers are decimals basically, character, logical, factors, and even complex numbers. in terms of data structures, R supports vectors, lists, matrices, arrays, and even data frames. So these are arranged in terms of increasing order of complexity. So vectors are the simplest and data frames are quite complex. Not in terms of understanding, but complex in terms of the types of data that they can actually hold. Knowing when to use what is critical to the efficient use of R. So let's look at a few examples. So data types, we have numeric. So it can include numbers, decimals, logicals. It's a Boolean, either true or false. Complex, to I is short for square root of -1. Factors, high, medium, and low. And finally, characters could be names, fruits, for instance, could be anything. Data structures. So vectors are the simplest of data structures. They can hold data type of the same kind. For instance, you can have character vectors, numeric vectors, logical vectors, and so on. Lists are similar to vectors, except that they can hold all kinds of data. So matrix, for instance, is a two-dimensional vector, so they can again hold only a particular data type, but they are classified as rows and columns like a table. An array is multidimensional, so a two-dimensional array is a matrix, but they are composed of vectors of one data type. And finally, we have data frames, and they're the most commonly used data structure. They can hold multiple data types, and they're pretty much like Excel sheets. So a list, again, can hold all kinds of data. So it can have a vector, it can have a matrix, it can have an array, and so on. So it's basically a data dump with a lot of different data structures in them. So data structures with examples. So this visually represents the kind of data that different data structures can take. If you look at vector, for instance, it's a single color. In this case, it's blue. And there's only a row in this case. A matrix says rows and columns, again, of a single color, of single data type. Array is multidimensional. A data frame, a data table, has 3 different colors representing 3 different data types. A list basically contains all of them. So that's it for data types and data structures. In the next set of videos, we'll be looking at logical operators, conditional operators, loops, and so on. Hey everyone. So in this video, we'll be looking at conditional statements, particularly if-else statements. So let's get started. So conditional statements are also called repetition statements. So they can be classified as if-else, nested if, else if, else, and finally switch statements. Relational operators. R uses the following relational operators to evaluate statements. So you have the greater than, less than symbol, equal to symbol, not equal to, greater than or equal to, and less than or equal to. And also know the difference between the assignment operator, which is a single equal to, and an equality operator, which is a double equal to. Flow of control. So basically this is the order of statement execution, one after the other. Typically lines in R is executed in a linear fashion, with one line being executed before moving on to the next one. So conditional statements, for instance, allow us to play around with the execution of lines one after the other. And typically these conditions are booleans that evaluate either to true or false. This order of statement execution is actually called flow of control. And conditional statements allow us to determine which statements are to be executed next. So we can also leverage equality operators and relational operators to validate statements. The syntax of an if-else statement. So if condition expression, which is the primary condition, is true, then statement 1 is run, else statement 2 is run. Alternate syntax is if-else together. And here in this case, if condition expression is true, the same thing, statement 1 is run first. If it's not true, then statement 2 is run. So it's the same thing again, right? If the condition is true, then statement 1 is executed, else it jumps to statement 2. The if-else statement can evaluate wide variety of data types such as integer, character, logicals, and even complex numbers. So let's take an example of an if-else statement. So let's consider x equal to -5. If x is less than 0, it'll print a negative number, and if else x is greater than 0, it'll print a positive number. So in this case, x is equal to -5, so the output is a negative number. Now let's consider x to be a numeric vector with 4 different numbers, 5, 7, 2, 9, and we'll use an IFELSE statement, the second syntax that we looked at, and we'll evaluate whether the numbers are odd or even, right? So if it's true, then it'll be even. If this condition is false, then it will be odd. So the first 2 numbers are odd, the third one is even, and finally the last one is odd. So this one basically gives you, this particular operation gives you the remainder that may come out from, so x percentage to the first, for example, for the first example, 5 percentage 2 will actually give you a remainder of 1. Basically, if you divide 5 with 2, then the remainder is 1, which is not equal to 0. Since it's not equal to 0, it's a odd number. When you divide 2 by 2, there is a remainder of 0, which is equal here, so it's true. So then that gives you an even number. So now let's look at the syntax of a nested if, else if, and else statement. So first condition is the condition expression 1. If that is true, then statement 1 is run. If condition expression 2 is true, then statement 2 is run. And this is under else if. Now you could also have another else if that evaluates first condition expression 3. And if that turns out to be true, then statement 3 is run, and so on. So in this case, if none of the if or else if statements are true, then finally statement 3 is run. So it's the same point again. If condition 1 is true, then statement 1 is executed. If condition 2 is true, then statement 2 is executed. If none are true, then statement 3 is executed. Now let's look at an example of a nested if, else if, and else statement. Let's consider x equal to 0. If x is less than 0, we'll print a negative number. If x is equal to 0, we'll print 0. And if else, finally, x greater than 0, then we'll print positive number. So in this case, since x is equal to 0, it evaluates this condition to be true and therefore prints 0. Now for the switch statement, the switch tests an expression against elements of a list if the value evaluated from the expression matches the item from the list. So in this case, we have switch and there's an expression section and then there's the list section, right? So the expression can either be a numeric or a character vector, and cases are selected if there is a match in either position or name. We'll look at an example to understand this better. With multiple options, which actually works the fastest. So let's look at an example. So switch to, and then the list contains red, green, and blue. So when I type 2 here, it picks a second element from this list, which is green. In case if the number exceeds the available list of items, then it returns null. So for instance, if I used switch 4, red, green, and blue, then we have no matching item for number 4 in the list, so it will return null. So that's it for conditional operators. In the next one, we'll look at logical operators. See you there. Hey everyone, so in this video we'll be looking at logical operators and, or, and not. So logical operators and, or, not. So logical operators are the building blocks of programming, allowing the possibility of evaluating multiple conditions at the same time. Statements inside a logical operator are evaluated from left to right, and they can be used to evaluate operands of different data types. So for instance, you can operate a character or a numeric, it doesn't matter. Notation in R, the exclamatory mark indicates not, ampersand is for and the vertical line is for or. We look at the details and the differences between the single ampersand and the double ampersand, the same thing for or, in the later part of the video. Or OR statement returns true if any of its operands evaluate to true and vice versa. So we can represent this with a truth table. Here true is equal to 1 and false is equal to 0. The end result can be actually evaluated as min of sum of the conditions or 1. So for the first example, let's take true and false. So true is 1, false is 0. 1 plus 0 is 1. Min of sum of conditions or 1. So min of 1 comma 1 is 1. The second example, true is 1, false, true is again 1, so 1 plus 1 is 2. Min of sum of the conditions, it's 1 comma 2, so again it's 1 and it's true. False is 0, false is 0, 0 plus 0 is 0, the min of 0 comma 1 is 0, which is false. And then finally 0 plus 1 is 1, min of 1 comma 1 is again 1. So the mathematical representation is here and the exact true or false parameters are here. Now let's look at AND. AND statement returns true if all of its operands evaluate to true and vice versa. We can represent this with a truth table. Here true is equal to 1, false is equal to 0. The end result can actually be evaluated as a product of the conditions. Now let's look at the example. True is 1, false is 0. So 1 into 0 is 0. 1 into 0, 0. True is 1, true is 1. 1 into 1 is true again, which is 1. So all the three are 1s. Similarly, false, all the three are false. So 0. So false is 0, true is 1, 0 into 1 is 0, 0, 1, 0. And finally, the NOT statement returns true if the operand evaluates to false and vice versa. It basically returns the exact opposite result. So let's take an example. So we know that x is equal to 5. So x equal to 5 should return true. But the NOT statement actually negates the result and returns the opposite, false. So for instance, here we have defined x equal to 5, x equal to 5, and we have testing whether x is equal to 5, which should be true, right? Within the bracket it will be true, but not true is actually false. Now the difference between the double ampersand, single ampersand, and the double vertical lines and the single vertical line for the OR statement. So typically the double ampersand or the double vertical line for the OR is used if the vectors are of length 1 and the result 2 is either a true or a false. This is actually quite rare and we found using AND or the single AND or the single OR better. So the single AND or the single OR evaluates each and every element inside the condition and also returns a vector of booleans. We'll go through this with an example. So let's look at the first case. And so here what's happening is it's a vector, in this case -2, 0, and here in this case it's -2, -1. So basically and we have connected both with a single ampersand. So in this particular situation, so C is -2. So the first one, -2 is greater than equal to 0, is actually not true. So it will return false. And similarly, C -2 is less than equal to 0 is true. But false and a true is still false. And that's why you have the answer here as false. For the next part, 0 is greater than equal to 0, which is true. It's equal to 0. And -1 is less than equal to 0. Yes, it's less than 0. So this is true. This is true. The combined result is also true. Now let's look at the double ampersand symbol. In this case, -2 is greater than equal to 0 is a false statement. And -2 less than equal to 0 is a true statement. Right? So false and a true is actually false. For the second part, both of them are actually true. So 0 is greater than equal to 0 is true, and -1 is less than equal to 0, that's also true. But basically what's happened is it's taken false and true and eventually it's returned false here. It's something called short circuiting. So basically here we've got individual breakdowns. So the first statement was false, the second statement was true, and we've got the breakdown of false and true. The false and true can further be combined to give you a final output which is false. And so with the double ampersand, you're getting the final output of this line of statement, whereas with the single ampersand, you're getting just individual elements, right? So this is a process called short circuiting. Now let's look at the OR. Again, -2 is greater than equal to 0 is false. and minus 2 less than equal to 0 is true. But with the OR statement, as I mentioned earlier, it's the min of sum of the conditions. So false is 0, true is 1, 0 plus 1 is still 1. So the end result is true. For the second part, 0 is greater than equal to 0 is true. Minus 1 less than equal to 0 is also true. So both are true. So true and true. And this is a single OR symbol. So we've got two answers. Now for the combined answer, since we've used the double vertical line here, the double OR sign, so here in this case, true or true is finally still true according to short-circuiting method. So that's the difference, and hope you guys enjoyed learning the basics. See you in the next one. Hey everyone, so in this video we'll be looking at repetition statements or loops. So repetition statements can be classified into two categories, while and for. So repetition statements allow us to execute a statement or a block of statements multiple times. Often they're referred to as loops. So like conditional statements, they're controlled by Boolean expressions. So it's either a true or false. And R has two kinds of repetition statements. One is while and the other for. So the programmer must choose the right kind of loop statement depending on the problem. So the for statement, so for condition 1 and then a statement. And this is the syntax that's typically used for the for statement. So if the condition 1 evaluates to true, the statement inside the block of code is run. So the statement is executed repeatedly until the condition becomes false. Here typically the condition specifies a set number of iterations equal to the length of the vector or the rows of a data frame. So what I mean by that is, for instance, you may want to loop through each and every row of a data frame. And in that case, you can specify the length being, say, for instance, 100 rows. Then you specify an iteration for 100 times and so on. So it's run each time and it evaluates each row for the particular condition. If it's either true, then the statement inside is run. If it's false, then it's ignored and then moved on to the next row and so on. So the for statement, let's look at an example. Let's consider a vector x with some elements. In this case, it's a numeric vector, and count equal to 0, again a numeric vector. So for val in x, so val is basically the number that is iteratively changed inside of the numeric vector x. So if val %2 is equal to 0, count is equal to count plus 1. So each time val takes a new value from x. For the first time, val might be 2. So 2 %2. This basically gives you the remainder. 2 by 2 is actually 0. So in this case, the condition would evaluate to true. And if that happens, then count is incremented by 1. So count here basically counts the number of even numbers in this vector. Right? So we have an even number here. We have another even number here, here, and here. So there's a total of 4 instances. So when you run this for loop statement, you should get an output that's equal to 4. That is gotten from the print statement here. So print of count should give you 4. So the above example, the for loop is run exactly 7 times. So 7 times because it's a vector of length 7. Now logic of a for loop, it checks for each item as part of a sequence. If the last item is reached, then it exits the loop. Otherwise, it continues looping inside, evaluating each item with a condition. If the condition is true, then the loop is run, the code inside is run. If it's not true, it's skipped, moved on to the next one until the last item is reached. The while statement, again, it's a similar construction. So while condition and then statement is provided. So if the condition is true, the statement is executed. And the condition is evaluated again. And if it is still true, the statement is executed again. So the statement is repeated multiple times until the condition actually becomes false. I can explain this with an example. So let's look at this one. I is equal to 1. So long as I is less than 4, you keep printing I and also increment I by 1. So for the first case, I is 1, right? So 1 is less than 4. This condition is now true. and then the next part is it prints 1 and then increments I, which is 1 now, as to 2, and 2 again is less than 4, so it prints 2 and then increments I, which is 2 now, to 3. 3 is again less than 4, and then again print of I, so it prints 3, and then I from 3 now becomes 4. 4 is not less than 4, so the while loop is closed here. So the final output is 1, 2 and 3, the iterations that are printed. So if the condition of a while loop is false initially, the statement is never executed. Therefore, the body of a while loop will execute 0 or more times. So the logic of a while loop, you start and you evaluate the condition is true or false. If it's true, execute the block of code inside the while loop. If it's false, execute code outside of the while loop. So it goes to the next line immediately after the loop. Infinite loops. This is quite often a trap inside of while loops. So the iterations will have to eventually make the condition false, initial condition false. If that is never nullified, then the loop will keep continuing and you will never be able to execute it. So it will result in an infinite loop which will execute until the user interrupts the program. This is a very common error. You should always double check the logic of a program to ensure that your loops will eventually terminate. Controlling loops. There are multiple ways to terminate a loop or selectively loop over particular items of code. There's one which is commonly used, which is the break statement. So this is used to break out of the loop at any point in time and move the flow of control to the line immediately outside of the loop. And then there is also the next statement which discourages a particular iteration. So let's say you don't want to iterate over I equal to 2. You can use that as a next statement and jump to 3 now. So there is next basically allows control within the loop as to which iterations are run and which are not. Break statement is used to exit the loop completely. So let's try an example now using next inside of a while loop. I've highlighted next and while. So the number is initially 0. While number is less than equal to 10, right? So in the first case, obviously that's true. If number equal to 4 or number equal to 8, print paste, skip to the next statement as number is not part of the series. So we're going to consider a series where we're going to evaluate every number. But if they are equal to 4 or 8, we skip that, right? So here it'll print this statement and say that that number was not iterated and is not part of the series. And then it'll skip to the next number. Otherwise, if it all runs through, it'll print the values are and then the particular number, right? And the number is then incremented by 1 and then again evaluated from here. So let's assume the first example. So number is 0, 0 is less than equal to 10, which is true. Now if number equal to 4 or number equal to 8, so this block of code here is not run because the number is not 4 or the number is not 8. Print paste values are, and then you basically paste the number. So values are 0. Now 0 is now incremented by a step of 1 and now number becomes 1. 1 is less than, sorry, I'll go to the previous slide. 1 is less than equal to 10, which is true. Again, 1 will not satisfy this condition. It'll directly move to this one and then again get incremented by 1. So this continues until we reach 4 where this becomes true and then basically skip to the next statement as the number here 4 is not part of the series. And then again 4 is now incremented by 1 and then move to the next one. So this is the process of controlling flow inside of a while loop using the next statement. Now let's look at a next statement inside of a for loop, right? So number is a sequence from 1 to 20 as shown here. Now while would assume a number from each of that sequence, so incrementally. So for the first time it might be 1, second time it might be 2 and so on. If the number is even, then you say the number is an even number and we will selectively skip 13. Otherwise we print odd, right? So we're going to print even and odds to every number except for 13, which we will skip, right? We're deliberately doing this to try out next. So what's going to happen? First step, 1 divided by 2 is, the remainder is not 0. So it will print val is an odd number. So 1 is an odd number. Then again, val is now incremented by 1. So 1 plus 1, 2. 2 divided by 2, the remainder is 0. So this is true. Then it says 2 is an even number. It'll continue until it reaches 13, where this one now becomes true, the else if. And what will happen is, it'll print this statement. We have skipped 13 and then move to the next number. So it'll go to 14, and 14 by 2 is equal to 0 is true. So that's going to give you 14 is an even number, and so on. So when to use while and for loops. So for loops can broadly be classified as a subset of while loops. So pretty much whatever you can do in for, you can do in while, but the vice versa is not true, right? And a for loop is often used if and only if you know the specific number of iterations required beforehand. If you don't know that, if you're still guessing the outcome, then it's best to use a while loop. So a for loop can also be used without a condition, it's the initial condition, and then what might happen is it might cause an infinite loop. However, a while loop will never run without a condition, and it will return an error. So every for loop can be reconstructed using while, but the reverse is not possible. So besides the while and for loops, there are other looping functions too in R. This is currently out of scope, and we can take this in the next one. So one is the apply family of functions, including mapply, sapply, tapply, etc. Then we have the repeat functions, the replicate functions, and currently these are out of the scope. So that's it, guys, with looping functions. See you in the next one.
Hey everyone, welcome back. So now that we know the basics of programming, it's time to get your hands dirty in real R code. Let's begin by looking at vectors. So in its simplest form, a vector is an object that consists of elements of a similar data type. Let me explain this with an example. I'll begin by defining a character vector V consisting of 3 strings: apple, orange, and banana. So it's a concatenation of the 3 fruits: apple, orange, and banana. Yeah, and let's run this line of code. And as you can see, the character vector V with the 3 fruit names. Now let's verify its type. So class of V should give you character. Now to view the elements inside the vector, we can simply print them on the console. So we print them here. So let's do that. Print of V should give you the 3 fruit names. Now let's say you want to specifically return elements inside the vector. So we can do this by specifying their positions in the vector. The square brackets are used for indexing, and the numbering in R starts from 1. So what I mean by that is V of 1 is apple, V of 2 is orange, V of 3 is banana. So let's try returning just banana. So V of 3, so notice the square brackets should give you banana. Now let's try returning groups of elements together. So let's try now apple and orange together. So V of 1 is to 2 should give you apple and orange. Now you can get the same answer by just removing banana from V, right? So let's try that. V of minus 3 will delete the third element and give you apple and orange again. Now let's say you want to assign names to these fruits. I mean, right now v of 1 gives you apple, but instead of calling it 1, can we call it fruit 1, for instance? So we can do that, right? So v, in this case, names of v. So the names function is used. So it's a concatenation of fruit 1, fruit 2, fruit 3. Let's run this. Yep, it's a named character. Now let's do this. Fruit 1. Fruit 1, apple. So that's how you name the different elements. So instead of specifying the position, you can call them by names too. Now let's try combining two vectors. So what I mean by combining is, let's consider something different for this example. Let's consider two vectors, v1, which is an integer vector. So 1, 2, 3, so numeric. v2 is concatenation of false, and true. This is a logical vector. Now if I did v1 or v2, I get 3. And the reason why I get 3 is this. So here the first two positions are false and the last position is true, right? So just consider it this way. False equal to 0, true equal to 1. So if I say v1 or v2, I'm going to be returning positions which are true in v2 in v1. So in this case, it's false here, so 1 is 0, 2 is 0, and 3 and 1. So v1 or v2 is 3. Now let's say you want to modify specific elements inside the vector, you can just do that as well. So for instance, let's say I want to, so let me first print v1, and then let's say that I want to take this 2 out and substitute that with 4. So this is the second position, so v1 of 2, and notice this assign symbol. That's it, right? Now if I do print v1, I get 1, 4, 3. Now let's say you want to delete specific elements inside the vector, you can do that as well. So v1 of -2 should give you 1 and 3. Now if you want to remove all the elements inside the vector, you can assign the vector to be null. So this would remove everything inside the vector. But you have v1 defined, but it's null. Now let's say you want to remove v1 itself from the environment, and you can do that as well using the rm function. Rm is short for remove. So rm of v1 will remove the vector from the environment. Now vectors can be extended to characters. We saw that in the first example. It can also include integers, as we had seen here, booleans as well, and even complex numbers. Let's look at a complex number example. Let's define a new vector z, which is 1 plus 2i. Notice z, 1 plus 2i, and let's try to find out the nature of the vector. It says complex. Now let me do this. Let's try square root of -1. You get this warning message because the solution to square root of -1 is not in the realm of real numbers. So when we talk about square root of -1, we're talking about a solution which is a complex number. So if I just replaced square root by -1 plus 0 I, now you should get a feasible answer, which is I. So basically I is nothing but root of -1. So if I square root of -1, so it's basically square of root of -1, then that should give me -1. Hence the answer I. Now we can also include vectors with other functions. For instance, I can just say seq, which is short for sequence, specify the lower limit, then the upper limit, and then the increments by 1, and then let me print v. So it's 5, 6, 7, 8, 9. So the lower limit, the upper limit, and the step increments of 1. You can also do this. V is 5 is to 13, and then if I just print v again, sorry, it gets the small v. Yeah. So 5, 6, 7, 8, 9, 10, 11, 12, 13. Again, you have a series with increments of 1. We can do this with decimals as well. So we call them floating point numbers. Print v should give you a 5.8 to 12.8. 13.4 does not belong to the series. So if you're looking at stepwise increments, it's 5.8 plus 1, 6.8, plus 1, 7.8, and so on. So 12.8 plus 1 is 13.8, which is above the upper limit. So it stops at 12.8. If you notice, print the class of B, actually, it says numeric. So R is an interpreted language, so you don't have to go about specifying the kind of numeric vector you're describing it to be. So for instance, here we're saying V is a vector, it's a numeric vector, but you don't have to go about describing it as a numeric vector containing floating point numbers or containing integers, for instance. So that level of definition is not required. So R itself would be able to understand most of that. Now let's look at this feature again. Let's try defining a new vector, which is concatenation of 5, ABC. So I told you this earlier in the previous section where we described about data types. I mentioned that vectors cannot hold multiple data types. If you need that feature, lists and data frames are good data types that could hold multiple data structures that could hold multiple data types. But with the vector, that's not possible. So in this case, let's try running this code. It should not be feasible, right? Let's run this and it actually passed through. Let me print V and I get 5 in ABC, but there's a catch. So I'll do class of V. Now look at this, it says character. So what's happened here is that V contained a numeric as well as a character, but a vector cannot hold multiple data types. So in this case, it was convenient to include both 5 and ABC as characters, because the reverse might not exactly be possible. I mean, the vector could not have converted by any chance converted ABC to be a numeric. A more safer conversion would be to consider 5 to be a character. And as you can see, class of V is a character vector. So now that you know what vectors are, we'll explore them further in the next video. I'll see you there. Hey everyone, welcome back. So in this lesson, we'll look at specific functions relating to vectors. So to begin with, let's define V1 as the concatenation of three numbers 1, 2, and 3. Let's also define V2 as the concatenation of three different numbers 2, 3, and 4. Now, in order to add or subtract vectors, they must be of the same length. And we can actually use the length function to see what the length is. So length of V1 is 3. So in order to add V1 and V2, let's define a new vector. Add vectors. So here the hash sign is used to take notes. So V3 is V1 plus V2. There you go, V3 is V1 plus V2, so 1 plus 2, 3, 2 plus 3, 5, 3 plus 4, 7. Let's also try subtract vectors. V4 is V1 minus V2. There you go, 1 minus 2 minus 1, 2 minus 3 minus 1, 3 minus 4 minus 1. Now in order to multiply or divide vectors, they need not be of the same length. So let's define a new vector. So first multiply vectors, and now let's define a new vector V5, which is 2, and let's create another vector V6, which is the product of V3 into V5. So V6 is 3 into 2 6, 5 into 2 10, 7 into 2 14. If you want to divide vectors, same procedure. V7 is 2, V8 is V3 divided by V7. So here what's happening is V3 is 3 by 2, 1.5, 5 by 2 is 2.5, 7 by 2 is 3.5, and so on. Now let's try to find remainders of a vector when you're dividing two vectors. So we look at an exercise where we'll evaluate numbers inside a vector and call them either even or odd. So if they are even, then it's true. If they're odd, then false. So let's create a new vector, V, concatenation of 3, 5, 4, and 2. 3, 5, 4, and 2. And now we're going to define another vector V1, which is 2. So when I try to run the remainder operation between 3 and 2, in this case it should be 1. So 3 by 2 should give you a remainder of 1. 5 by 2 also the same thing. 4 by 2 should give you a remainder of 0. 2 by 2 should give you a remainder of 0. So I'm going to be leveraging the if-else statement here. So if the remainder is 0, then it's an even number, and if there are remainders remaining, then it's an odd number. So let's use that. So V2 is if else of V, and if this is the remainder is 0, then it's true, else false. So V2 is now false, 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 true. Oh, we should have done the other way around. V5, V1. Yeah, now it's correct. False, false, true, true. The first two are odd, last two are even. Now for arithmetic operations, R typically follows the DMAS rule, which is division first, multiplication, addition, and finally subtraction. So let's try this with an example. So let's define a vector V, which is 2 plus 3 into 5 by 2 minus 9. So here the first step according to DMass is division. So it's going to divide 5 and 2. So 5 by 2 should give you 2.5, and then multiply 3 into 2.5 should give you 7.5. Then add 7.5 plus 2 should give you 9.5, and finally subtraction. So 9.5 minus 9 should give you 0.5. So let's run this code. If you look at print b 0.5. So there are other observations as well. For instance, you can do the absolute function, which gives you the absolute, the positive value for any negative integer. So for instance, let's do absolute of minus 2.5. That should give you plus 2.5. Now let's say we have decimal numbers and you want to round them off to the nearest whole or natural number. There's a simple way to do that using the round function. So let's define a vector now. B is 2.5, and if I use round of v and specify the digits to be 0, that should give me the closest one. So in this case it's 2. We can also specify where we want to round the number off to. Now let's say in this case we wanted to round the number off to 3. Using the round function it's not possible, and that's where R has two functions. One is called the floor, the other the ceiling. The floor is the minimum or the lower limit of the round operation. So if I did floor of v, I'd get 2, but if I did ceiling, I should get the one above, 3. Now let's try a few exercises on character vectors. So let's define a character vector v, concatenation of a, b, and c. Now let's say you want to locate the second position of the element. You could just do v of 2. But let's say you want to see if the element itself is there, or you don't know if where the element is located. Then there's a useful function called the grep function, which we can use to find out where the position is. So for instance, if I use grep of b, so I'm going to look for the alphabet b inside of the vector v, and it says 2, which means that it's on the second position of character vector. So that's it, guys. We look at more character vector operations in the next one. See you there. Hey everyone, welcome back. So in the previous lecture, we learned how to modify strings. Now we'll take up an interesting exercise to convert words into its Pig Latin form. So for instance, let's take the word dictionary. Now, this is a regular word. So in its Pig Latin form, it's going to read something like this. Dictionary day. Similarly, let's take another word, mango. And this one, in its Pig Latin form, it's going to read ango -may, angomay, right? So how it works is, it takes the first letter and then moves it to the last. ANGO stays as it is, and there's a hyphen after the last letter, and then the first letter comes here, so M, and then AY is standard. The AY is why it's Pig Latin. So let's try this example in R, right? So that we've understood what the concept is, let's try it out in terms of code. So let's define a vector v, which is dictionary. Now let's say we want to remove the first letter. In this case, we want to remove D. There's a simple way to do that using the sub function. So let's assign that also to the vector v1. So here, the single dot refers to the first letter, right? So in this case, we just want to remove D, right? So that's the single dot, and then the rest stays as it is. If you look at v1 now, it just says dictionary, right? So D is dropped. Now in order to get the big Latin word, we can assign it to a new vector, use the paste function. The paste function does what the name suggests, basically pastes two vectors. So let's paste v1 with day. So we're pasting v1 with day. The only thing that remains between the two is the hyphen, which the paste function actually supports using the separator code here. So v2 gives you dictionary day. But there's a problem. So this lines of code can only be executed for words that start with the letter D. I mean, if I were to use mango, for instance, this cannot be replicated because of hard-coded D here. AY remains the same, but D should be replaced now for mango with M, and so on. So in order to replicate code, we're going to use a different set of functions. As the first step, let's assign the first letter to a new vector called first letter. So in this case, you're going to use something called the substr function. So substr would pull out letters, groups of letters and so on from words. In this case, it's going to pull out the first letter. So substr of v is the entire word dictionary. Start equal to 1, so this is where it starts, and stop equal to 1. So it's going to pull exactly one letter in the first letter in the word. So first letter is D for dictionary. Now we're going to use the paste function. Actually, before that, we'll have to define another vector which has the word D dropped out. I think v1 already has that, so I think this can be as it is. So paste v1, so dictionary is pasted as it is. And then we're gonna use another paste function to combine first letter and AY. But this time there will be no separators between the two, but there will be a separator between v1 and the paste function here. It's this separator, right? So ICP equal to this, and that should give you the answer, dictionary day. Now let's try this with another example. So let's replace v with the word mango, and character. So V is mango, the first letter is M, and V1 is going to be mango, and if I paste this, mango may. So now we've replicated the code, and we can pretty much replace V with any letter we want, and we should be able to generate its Big Latin equivalent. So that's it, guys. I'll see you in the next video. So in this video, we'll look at character vectors in detail and a few functions relating to that one. So let's say we want to repeat a pattern multiple times. R has a feature called rep that helps you with exactly that, copying patterns over and over again. Let's take an example. Let's define a vector, the concatenation of 3 strings, A, B, and C. So let's create a new vector, vec1, which is a concatenation of rep. Vec refers to the first vector, vec, comma, 4, and then D and E. So in this case, what's happening is we're repeating the vector ABC 4 times. That's why it's inside the rep function. And then finally, as suffixes, we have D and E. So if you print vec1, you should see the pattern. There you go, ABC, 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 and ABC. So 4 times, and finally D and E. Now let's try this example. Let's create a new vector, vec2, which is rep of vec length dot out equal to 10. Print vec2. So see what's happening here. So we have specified length dot out, so which means that the max length of the vector would be 10. So a pattern would be followed, but only up to 10 different elements. So in this case, what's happening is ABC is one set, this is a second set, third set, that itself is 9 elements, then finally just 1 from the fourth set. Besides this, there are some very useful functions relating to vectors, especially character vectors. So we can do some checks. For instance, let's say we try to find out if there's a vector, a letter D inside of the vector that we have. If I do this, it says false because there's no D inside of vec. We only have A, B, and C. Let me try with C, and it should give you true. Okay, so there's a fundamental difference between all and any. So for instance, all is used whenever you're looking at comparing all elements inside the vector, as the name suggests, right? Whereas any is used only for only if the element is inside the vector or not. It's just a check, right? Check for elements inside vector, right? So in our condition right now, we've used any vec equal to C. So we're checking if there's any element inside a vector which is equal to C, and there is one, and that's why we got true. Now there are other functions such as which is commonly used to return the position of an element inside the vector. But unlike grep, which is exclusively for characters, they can use which to return positions of numerics and booleans as well. So it's more versatile that way. So let's consider an example in this case. So let's create a new vector, v, which is a concatenation of true and false. Now if I'm going to use which, v equal to true, it returns 1. Basically, it's locating which element inside of v is true. In this case, it's the first element, so it's true. So as I mentioned earlier, which is more versatile and should be often used. And in my experience too, I've used a lot of which as compared to GSUBs because it's more versatile, along with all and any as well. So that's it guys for this video. In the next one, we'll look at data frames.
Hey everyone, welcome back. So in today's lecture, we'll talk about lists. So think of lists as a data dump that allows you to store all sorts of information to it. Data structures can include vectors, matrices, data frames, and even lists themselves. Multiple data types, including characters, numerics, booleans, and even complex numbers. Lists are ordered arrays, and individual elements can be accessed by square brackets. So you basically just have to mention the name or the position. So let's now go ahead and create a list. So as a first step, download the data set that's provided with the lecture. It's the film dataset. So download that and let's import the dataset into R. So go to File, Import Dataset from Excel, hit Browse, go to Desktop, search for film, and you should see a preview of the dataset. Hit Import, and that should import the dataset. So in this case, if you see, for instance, the first column has the years, the second one has movies. So all of these are Steven Spielberg's movies, by the way. The reviews, all of them are from IMDb. Lead actors for the film, budget, box office, and some comments about the film. So let's go and save this to data. Yeah, so it has the same set of observations. Now we'll create a vector for reviews, and what you want to do is you want to find out the average rating or average review. So my underscore vector data dollar reviews. So this should store all of the numerics. Average rating. So if I find the mean of my vector, I should get average rating at 7.64. So this is the typical rating of a Steven Spielberg film. Now, so we know the average rating, the average review. We want to find out which actor was cast most frequently, at least in this list, right? So for instance, if you look at Tom Hanks, I can see one Tom Hanks here, one here, one here. I can see Harrison Ford in both of this. So I want to find out which actor was cast the most in this list. And so for that, we need to install a package. It's a STRINGR package. So let's go ahead and install this. Install package. The STRINGR package. Yep, so it's done. And now let's run the package. So library STRINGR. The STRINGR package has a very useful function called strsplit, and that'll help you split strings based on some parameters. So in this case, if you see, splitting point is the comma. So if I were to split Daniel Craig and Eric Bana, I would use the comma and get two different actors, right? So split underscore names is equal to strsplit date dollar theta dollar lead dot actors, and this is the separation point, right? So if I run this code, I should yeah, lead should yeah, I think it's with labeling. It's lead space actors. So I'll just copy this here. Yeah. So split underscore names, and if I open this, I can see so Jeff Goldblum, Laura Dern, Daniel Craig, Eric Bana, Leo DiCaprio, Tom Hanks, and so on. Now we need to extract all of these names out of the list. So here we have a function called unlist that comes in very handy. So list creates a list, unlist removes a list, right? So in this case, if I do split underscore names, unlist of split underscore names, I should get all of the names now as a character vector. Now I'm going to save this to a data frame called names.df, names underscore df, and it has all of the occurrences. Now I'm going to use the DPLYR library. Yeah. And what you're going to do is now you're going to create a character vector containing the most featured actor. So the most featured actor is names underscore df, which we have, which is a data frame. It's going to count the number of names and slice out the max occurrence. So if I do this, I should get one observation of two variables, Tom Hanks 3. So what it's doing is it's basically counting the number of occurrences, and then it's slicing out the one with the max occurrence. Now let's just save it out as a character. Now let's create a new data frame containing movies featuring only Tom Hanks. So there's a function called str_detect that looks for words that are similar to Tom Hanks in the lead.actors column. This is again a very useful feature in STRINGR. So if I'm gonna just filter for Tom Hanks movies, irrespective of whether he played lead actor or a supporting actor. So Tom Hanks underscore movies, data, filter, lead. It's not dot actors, but it's lead actors and most featured. And I'm getting basically 3 movies: Catch Me If You Can, Saving Private Ryan, and The Terminal. And by the way, all these are fantastic movies. You should watch them if you haven't. So now let's create a matrix of box office revenues and budget of movies not featuring Tom Hanks. So let's build a data frame that returns the remaining rows. Here we can simply do a set diff that returns the difference between data and my underscore df. Okay, so basically set diff helps you differentiate between two data frames. So we already have Tom's Hanks underscore movies, which is a data frame with the 3 movies. Obviously this is a subset of the data frame. So we want to find out what the remaining movies are. So if I use set diff data, which is the bigger data set, Tom Hanks underscore movies is a smaller data set, I should get no Tom Hanks underscore movies, right? Or movies that don't feature Tom Hanks at all. And now we're going to build a matrix of box office revenues and budget of movies not featuring Tom Hanks. So we've got the data set, which is this. We need to extract budget and box office from this one. So budget underscore box office is a matrix of n row of no Tom Hanks underscore movies and n col equal to 2. So we have defined the number of rows to be, in this case, 7, and number of columns as 2 because we just need budget and box office. I'll run this code now, and budget underscore box office 1 is no Tom Hanks underscore movies budget, right? So I'm taking the budget and assigning it to the first column. Again, maybe there's an issue with the labeling. And the one with the box office figures. Yeah, and we can check this now. Here you go, right? So the budget and the box office figures. Yeah. Now let's label rows as film names and columns as budget $1,000,000 and box office $1,000,000. So row names would basically take all of these names, right? So it's done here. The column names would be the 2, and let's print it out now. Great. So let's now create a list combining all of these elements. So we first found out average rating of a typical Steven Spielberg film. We also found out the most featured actor, which is a character vector. Average rating is a numeric vector, by the way. Budget underscore box office is a matrix, and Tom Hanks underscore movies is a data frame. And all of this is going to go into my underscore list. Now let's print the list. And the fourth item in the list, which is most underscore featured, it should show Tom Hanks. Yeah, it does that. Now let's try naming the elements inside the list, right? So the first one is Tom Hanks underscore movies. So we'll call it movies featuring Tom Hanks. The second one is budget underscore box office. So we could call it budget and box office sales of movies not featuring Tom Hanks. Average rating is average IMDb rating. And most featured is most featured lead actor. So I've labeled the list now. So if I'm going to call it by list now instead of the number, I can do that as well. All of the movies featuring Tom Hanks, right? As a lead or co-actor. Now let's add a new element to the list. Let's find the median box office sales of all of Spielberg's films. So median underscore sales is data dollar, and let me just change this. And my list of 5 is median underscore sales. The reason why I say 5 is it's the fifth item. We're adding a new item to the list now. And if I print that, I should get my median box office sales. Now let's also add the primary data frame to our list, the one where we sourced all of this data from. So we can just do concatenation of my list and list of data, right? So this is already existing. We're concatenating this as well. Now we can label the recent additions to the list. So names of my list 5 is median box office, and names of my list 6 is Steven Spielberg movie dataset. Now let's say you want to delete items from the list. You can just call it and assign a null to it. So if I'm going to delete median box office $1,000,000 that we just added here, I can do that by calling it null now. So let me print my underscore list, and there you go. So the first item is the IMDb rating. Then we have the most featured lead actor, Steven Spielberg movie data set. Also we have the budget and box office sales of movies not featuring Tom Hanks, and we also have movies featuring Tom Hanks. Yeah, the same order, right? So 1, 2, 3, 4, and 5. So that's it for lists. See you in the next one. Hey everyone, welcome back. So in this lecture, we'll be discussing about matrices. A matrix can be thought of as several vectors arranged into a symmetry of rows and columns. So they can either be a square or a rectangle. Like vectors, they're composed of elements of a similar data type. So they can either be a numeric, a character, a complex, or a logical number. In order to understand this concept better, we can try constructing a matrix from multiple vector objects. So we'll try to create a 3x3 matrix using rbind. And for this, we'll take up some country stats such as GDP, the population, and the average life expectancy in years. So I've defined 3 countries here: Avalon, Buranda, and Ambrosia. And I've mentioned the parameters. So the first one is the GDP, population, and years. So I'll run these 3 lines of code, and we have created 3 different numeric vectors. Now mat1 is basically the rbind of all of this. Obviously, if you're binding vectors, they should create a matrix. So we have mat1 created now, and class of mat1 is matrix. Now I'll open up mat1 and show you how it looks like, the updated one. So yeah, so we have the vector names here. And for columns, we have v1, v2, and v3. There is methods to rename the rows and columns. And for that, you'll have to use the dim names function. So dim names of mat1 and it's going to be a list with the current with the country names and the column names, right? So I'll run this, and now let's check the change. Yeah, it's now reflecting on the screen, right? So you have the country names here and the parameters as columns. You can also generate a matrix using the matrix function. So you'll basically specify matrix of n rows. So in this case, we had 3 rows for the 3 countries, n calls, 3 columns for the 3 parameters: GDP, population, and average life expectancy. And then you can just use the dim names and define the names of the rows and columns. So if I run this, I should get a null matrix with the names of the columns and the names of the countries populated. And then you can just source. So for instance, if it's mat2, I can just say mat2 1. So that refers to the first column in the matrix, sorry, first row in the matrix. And then I can just say that's the same thing as vec avalon, and mat2 2 comma, and I can say that's the same thing as vec underscore buranda. And finally mat3 mat2 3 comma, and that's the same thing as vec underscore ambrosia. And now if I open up mat2, the values are populated. So let's say now that you want to only select rows 2 and 3 and display all the columns, right? You can do that as well. So for instance, I can just do mat1, and then I can just say rows 2 and 3 and all columns. So that should just display buranda and ambrosia. So the indexation works as rows in the first part. So the ones before the comma are rows, and the ones after the comma are columns. Now if I do this, for instance, mat1 of 1 comma, I get this parameter. Now if I want to find out what the class is for this particular row alone, it's a numeric vector. As we had covered earlier, matrices are composed of vectors. So when I just take the single row and I try to find the class, a single row is nothing but a vector element. Now let's say we want to find out, based on columns, we want to find out the GDP of all the countries in our sample size. I can just reference the column name, and that should give me the 3 GDP values for the 3 countries that we have here. And I can also change the values. So for instance, if I do mat1 equal to 500,000. So it's going to replace all the 500,000s inside of mat1 with maybe 500. So let's try this, and I'll do print of mat1, and there you go, right? So basically what's happened is it's changed 500,000 in GDP to 500 now. This is obviously the same thing. It was 500 even before this, but this one has changed. So now that we've understood how to create a simple matrix as well as modify elements in them, we'll try out a few exercises in the next one. See you there. Hey everyone, welcome back. So in this lesson, we'll be looking at performing basic operations on matrices. So quickly go ahead and load the dataset given with the lesson, the marks dataset. So I'll just show you how to do that. So go to File, Import Dataset from Excel, and then navigate to where it's stored. So Desktop, Marks 1, and it should show you a preview. Click Import, and you should see the dataset in the environment. Now it's a data frame. In this case, it's so class of Marks 1 would give you what it is, data.frame. And we're going to be building a new matrix now. So report is the name of the new matrix. And in this case, if you look at the data set, we have, I think, 5 students. Yeah, there are 5 students and 5 different subjects. So we're going to create an empty matrix with 5 rows and 5 columns. So let me go ahead and create that first. So report is now created. It's an empty matrix with NAs. Now let's populate the report matrix with the numbers from marks 1. So we know that a matrix can only contain data types of the same type. So in this case, we're thinking of populating the matrix with numbers. So we can only populate numbers and not names, because that's a different character. So if I'm going to be doing this, as.matrix is used to convert the data frame, because marks 1 is actually a data frame, to so as.matrix is used to convert it into a matrix. And we've also used this sort of indexing where the first set before the comma refers to rows, the second set after the comma refers to columns. So since we want to only filter out columns, we're using the numbers after the comma. So report should now contain numbers of all the scores, across all the 5 subjects. Now we need to name these columns as well as name the subjects. It's already there, so just the names of the students now as row names. So we're going to create 2 different vectors. One is the rows vector, which is going to store all of the names inside marks 1. So it's going to store all of these names horizontally. Columns, or calls in this case, is going to store all of the column names from 2 to 6. The reason why I've not taken all column names is because we also have the names which would show up, and we don't need that to show up, right? Because we only have 5 columns here. So let me go ahead and run those 2 lines of code. So calls has 5 subjects and rows has 5 student names. So dim names would basically name the rows and columns in a matrix. So you can use the list to import both the row names and the column names. So in this case, it's stored in rows and columns, and I'm using list to assign those names to the matrix, right? Let me go to report again, and there you go. We have the names of the students and the subjects they're taking, and the marks code is populated here. So the next step, we're going to calculate the individual averages that each student has scored across all the 5 subjects. So we're going to use a function called row sums. Row sums would basically sum across rows. So sum across the rows. This is going to sum 70 plus 65 plus 80 and give you a sum here, and so on for Adam and Rachel and so on, right? So it's going to sum across the row. Let me run this, and it's now saved as a vector. It's a numeric vector with 5 different values. Now we're going to populate the averages alone here, right? And it's going to be called student averages. So the first step, let's generate the average. Student average is total by n call of report. N call because number of columns, because number of columns represent the number of subjects the student has taken, right? So student average, and finally report is a C bind because I'm going to bind by column and not by row. So that should give you the student average bound to the report statement as a column. Now we're going to find out what are the class averages for each subject. So in this case, we're going to use something called call sums. So call sums is basically going to sum each item, each row in a column, and then give you a total here for English, total here for math, total here for science, and so on. So total and class average is basically total by number of rows, right? So we have 5 students, so by number of rows. And finally report is R bind because we're going to be binding it this way horizontally. So it's R bind of report comma class average. So it'll be the last row would be class average. And finally, let's just print report, and you should see the entire statement. So we have the class average in the last row, student average in the last column, and all of the scores by the different students here. So that's it, guys, with matrices. See you in the next lecture. Hey everyone, welcome back. So in this video, we will touch base on data frames. Data frames are two-dimensional tables containing rows and columns. Structurally, they are very similar to Excel sheets and can hold multiple data types. As an R programmer, you'll be working with data frames more often than not. So in this series, we'll try to cover as much ground as possible on the basic operations, functions, as well as libraries unique to data frames. Data frames can hold massive amounts of information. For example, let's take a look at the empty cars data set. So I'll just pull that up using the data function, and we can just run this. Yep. So if you navigate to the data frames, empty cars, you can see that there's about 32 different models of vehicles, and they're classified on multiple parameters. So you have miles per gallon, cylinder, displacement, horsepower, and so on and so forth. So as you can see, a data frame typically has rows and columns. So let's try to create one ourselves. Let's create the student data frame. So student is data.frame, which is a function that is used to create a data frame. The first column would be names. It's a concatenation of 3 students, Pete, Mark, and Eva. And then the next column is age, which is a concatenation of 12, 14, and 10, the students' ages. And finally, sex would be male, male, and female. And let's run this, and that should create the student data frame in the environment. And you have 3 names here, 3 different ages, and 3 different columns for sex. Now let's quickly summarize the data set. Summary of student should give you the classification. So names is classified as character, which is correct. Age is a numeric with min at 10, max at 14. Fine here. Sex is also classified as character. Technically though, sex should have been classified as a factor, but we can do that as well, right? So student $sex would be as.factor, which is a function that's used to change the data type from one form to the other. So here I'll reference that column, and then let me run summary again. And there you go. It's converted sex to male and female, female 1 and male 2. So now it's a factor type. We can run a lot of other functions on this. For instance, let's use the endRow function of student. Should give you the number of rows. 3 endCol should give you the number of columns, which is also 3. So now that you broadly understand how to create a data frame and also change between data types, in the next video, we'll look at how to modify, add, or delete observations from data sets. See you there. Hey everyone, welcome back. So in this lecture, we'll be looking at indexing in data frames and also modifying, adding, and deleting observations. So let's continue working on the student data set. If you don't have it saved, download the Excel attached with the lesson. And I'll also show you how to import Excel into R. So once you download the file, click File, Import Dataset from Excel. Now navigate to the file. And once it's imported, you should be able to see the data preview screen with the different columns, and just hit import. And there you go, it's imported in the environment now. There are multiple ways to access observations inside data frames. One is by using square brackets. So for instance, I can use square brackets to reference the first part of the square brackets would refer to rows, and the second part to columns. The student 1, 1 should give you Pete. So it's the first row, first column. Now let's say we want to reference the age 14, Mark's age 14. That's second row, second column. So I can just simply type student 2, 2 and I should see that. We can also use dollar to reference column names. We had seen that in the previous lesson as well. So student dollar age 2 should still reference Mark's age and return 14. Now let's say we want to modify the elements inside the data frame. Again, we just assign a new value to the referenced position. So let's say we want to change Mark's age to be 16. Then I'm just going to say 16 here, and then let me reference this again. Yeah, it's changed to 16. We can also add new students to the class by using the rbind function. So let's try this. New student, and the student will have a name, Joanne, age 15, and sex is female. So create this. So it's a character vector, and then let's do the rbind. So student rbind student comma new student. And if you go and check this here, there you go. We have the new student added here, but there is a problem. So if I do class of student dollar age, it says character. Earlier it was numeric. The reason why that's happened is because we have created a vector, and the vector can take a single character type. In this case, it chose to take character for all of them. So we need to convert the class of the age column. So that's pretty simple. Student dollar age, and we're going to use the as.numeric function and reference the particular column here, and that should do the trick. So I'll run this code again, numeric, and we can check the data. It's the same thing, right? So that's it, guys. See you in the next one. Hey everyone, welcome back. So for this lecture, we'll look at a few useful functions specifically for data frames. So let's use the empty cars data set available with R. So I'll load that here. Data equal to empty cars. And if you look at the data set, we have about 32 different models of cars and 11 different parameters to compare them. So we have MPG, which is miles per gallon, SIL, which is cylinder, displacement, horsepower, and so on and so forth. Next, also, I will show you this cool feature on data frames. You can apply the filter function. It's similar to the filter that we have in Excel. So you can filter for, let's say, a 6-cylinder car, and you get 7 different matches, 7 different variants, and they have their own set of characteristics. You can do the same thing in R as well using the which function. So which specifically gives you the matches for a particular value. So for instance, here we are looking for cylinder, which is equal to 6. So it'll give you all the matches in that particular column. So for instance, I'll run this line of code. As you can see here, it throws up a bunch of different numbers. These are basically row numbers. So if you go to the data set, I'll remove the filter option. So the first row has cylinder equal to 6. Second row as well contains the same number. The fourth row, the sixth row, and so on. So these numbers basically give you the row numbers of the primary data frame. Now, how do we filter this, right? So in the last lecture, we had looked at how data frames are expressed or indexed, in fact. So the first part of the data frame is the row, and the second part is the columns. What I mean by that is, if I do data, rows, comma, columns. So if you want to filter based on rows, we use the numbers before this one. And if you want to filter based on columns, use the number after the comma. Yeah. So in this case, we want rows specifically, and we want all of the columns to display. So I've used all of these numbers here, and they will subset the data frame only for these rows, right? So I'll run this piece of code, and there you go. 7 entries, all have the 6-cylinder variant and all of the parameters. Now let's say we want to just compare MPG and cylinder. We don't need any of the other parameters. So we can do that as well, right? So we're going to use the right hand side of the comma for filtering out or filtering columns. So in this case, we need just the first and second column. So I've used 1:2. And if you run this line of code, you should just get the 7 entries, 6-cylinder engines, and all of the MPEGs. Vector-based filter. So now let's assign a value to a vector called sil. So it's 6 in this case, MPG, which is 21. So we want to look for models that have cylinder greater than 6, greater than or equal to 6, and miles per gallon exactly equal to 21, right? And we want all of the variants with all of the columns, right? And that's why this is used before the comma here, right? So I'm going to run this line of code, and it gives me one model, Mazda RX-4, which has MPG 21 and sil 6. Now let's say I want to order MPG in your increasing order. So we can simply do data order. So the order function would basically order data, and if it's positive here, then it's going to be in the increasing order. So in this case, we're going to order MPEGs in their increasing order, right? So let's run this line of code, and there you go. So Cadillac Fleetwood has the lowest MPG, understandable, and the ones with the highest fuel economy is Toyota Corolla at 33.9. And in terms of descending order, this is it, right? It's the same thing in reverse. Toyota Corolla comes first, right? Now if I do rev of order of minus data MPG, so what's happening here is it's first going to be using this order minus data $MPG. So it's going to be ordering them in descending order, right? So the highest comes first and the lowest comes last. Now rev of that is basically reverse of that. So now it's again going to push it back to increasing order, right? So this answer should be the same as this one, right? I'll run this line of code, and there you go. Yeah, Lincoln Continental and Toyota Corolla at the end of it. So that's it, guys. In the next video, we'll look at something really interesting. We'll look at the DPLYR function, one of the most popular packages in R, and we'll apply it to a real world example. See you there. Bye. Hey everyone, welcome back. So in this lecture, we'll be looking at an example for while loop. So let's get started. John is a trader who works for a top firm in Wall Street. He follows a long only strategy on Apple and buys the stock at the opening price. He does not carry forward any positions and will close out the trade irrespective of a profit or loss at the end of the day. A weekly bonus is paid out if the strategy works out a profit for 5 consecutive days. So we have to calculate how many weeks it takes him to net his first weekly bonus. Assume a week, in this case, to be 5 days, because we're not accounting for the weekends. Also calculate his P&L for the 5-day winning streak. So as a first step, go ahead and download the data set that is provided with the lesson. So it has the Apple stock returns for the last 1 year. And import the file as a CSV into R. So you'll use this code to import the data set, the CSV file, and you save it into data. Header equal to true basically accounts for the headers that are available in the CSV file. So let me go ahead and run this piece of code. And here I go. Data has about 252 observations and has 3 variables: data, open and close. Sorry, date, open and close. And you have the dates for the 252 day period. Now, a while loop is typically used for situations like this, right? I mean, you have to find out, first of all, what are the odds of achieving a 5-day winning streak, or here you want to know exactly when you would achieve it, and so on and so forth. Also, you don't know how many iterations you have to run in the first place to reach that answer. So in situations like this, it makes sense to use a while loop. It cuts down the length of code for you. So let's now define the variables that are required as part of the while loop statement. First is wins. So we're defining wins as a numeric vector, and here in this case it would be declared as 0. Similarly, attempts. So attempts basically counts the number of days it actually takes to achieve your target. So in the first case, we've assumed attempts to be 0. Profit is nothing but the difference between the closing price and the opening price. And this is calculated on a daily basis. So data $close. So dollar here refers to the column. So data is the data frame. So data is the data frame, and $close refers to the column here. Minus data $open. So data $open refers to the open column. So what it's going to do is it's going to basically subtract data $close minus data $open for each and every row and save it as a vector. So let me run this code. So profit, and I'll print this so you get a good idea as to what it is. So it prints out a series of numbers. So it's a vector, and we have about 251 here and 252 here. So that's equal to the 252 observations in the data frame. And then let's declare I to be equal to 1. Now the while loop, right? So basically we have I is less than equal to length of profit. So length of profit here in this case is the length of the vector profit. The length of the vector is 252. We can even check this. So I'll just type length of profit. Yep, it's 252. So I from 1 up to 252. And if wins equal to 5, then break. So we did this break statement earlier. This is used to break out of the loop. So if wins equal 5 at any stage, the loop is stopped, because we need the first occurrence of a 5-day winning streak and not every occurrence. And then the next part is inside the else statement. And here we have while wins is less than 5. So we have another while loop. The reason why we use a second while loop is because we want to find out incrementally how long does it take and what are the profits that are made until we reach the 5-win streak. So while wins less than equal to 5, less than 5 alone, if profit I is greater than 0. So profit I is basically, profit I refers to the vector here. So if profit I here is greater than 0, we increment the wins vector by 1 and we create a new vector called profits. It's different from profit. And what we do is I add profit I plus profits. So I'll take an example. So let me go to 120, 119, right? So 119 is where we have registered a profit. So when the loop was carried out, wins would have incremented by 1 and profits would have gone to 0.58. The second time a win was registered, wins would have incremented again by 1. So from 0 it would have gone to 1, and then from 1 it would have gone to 2 now, and profits would now show 0.58 plus 2.23 and so on and so forth. If the streak is broken, profits and wins are reset. Attempts, as I described earlier, calculates the number of attempts it takes to reach the 5-day winning streak, and weeks taken is recorded as I minus 1 by 5. The reason why it's I minus 1 and not I by 5 is because we're incrementing it. We're incrementing I by 1 prior to this. I mean, if weeks underscore taken were before this, then I would just use I by 5. So let me run this loop now, and we'll calculate the value. So it takes 41.2 weeks to reach a 5-day winning streak, and the profit that was made is 12.204939, and the 5-day winning streak was reached in 41.2 days. So that's it, guys. See you in the next one. Hey everyone, welcome back. So in this lecture, we'll be looking at an example for the for loop statement. Let's take up the same data set that we had covered in the previous one. So you'll find the Apple stock returns data set attached. So go ahead and download that. So in this example, let's consider another trader, Mark, who also works at the same firm, but follows a slightly different strategy. He buys Apple if and only if it closes above the 10-day average and closes out the position at the end of the day, regardless of whether it's a profit or a loss. So how long would he have to wait to achieve a 5-day winning streak? And what would his profits look like for the winning week? So let's get started. So let's first import the data set into R. So if you can look at the screen here, I've got the code for importing data set. So data, read.csv, apple.csv. So apple.csv is the name of the file and header equal to true. So I'm going to run this piece of code, and there you go. So we have a new data frame in the global environment. I'll run the head function. The head function would basically give you the first 5 to 6 records in the data frame. So if you can see here, we've got the date, the opening prices, and the closing prices of the stock. So this is from 2019 to 2020. So this is 12th July 2019. Now let me run the summary code. The summary code will help us understand the different types of data that we have. So in this case, we have the date, which is actually of class character, and we have 252 records. So this accounts for the roughly 1 year of trading history. And then the open prices have the minimum. So the minimum that Apple opened at was 195.4, and similarly the max price is 385.1. Apple typically traded between 268.1, which is the median or the 50th percentile, and the mean 271.6. This is the 1 year, or I could say 252 day mean. Similarly, for the close, we have the mean and the medians, and the minimum close was 191.1. So typically this was the lowest price that Apple closed at for the year, and max is the highest price that Apple closed at for the year, 383.7. Now, the next step is to find the rolling average. In this case, I should say the 10-day rolling average. So we'll build a new column to do that, and we'll call the column mean. So I'm creating a new column using the $sign. So the $sign is used to reference to a particular column, an existing column, or create a new column, right? So we don't have the mean column anywhere in the data frame so far. So I'm creating that using the $sign, and I'm assigning NA to it. So let me go ahead and run this code, and I'll show you the new data frame. So we have the 3 existing columns and mean column which has NA values in them. Now we'll have to find the 10-day simple moving average, but it's a rolling moving average, which means that technically speaking, if I'm on the 25th of July, my 10-day rolling average would be the mean closing prices up to 25 July. So from 200.9023, the first record, to the 10th record on 204.5785. So I'll take the simple moving average of these 10 prices and assign that to 25th of July. Similarly, 26th of July would consider the simple moving averages from 15th of July to 26th of July. So from 202.7896 until 205.2900. So all of this would comprise the second 10-day moving average, and it would be marked here. So you may ask, what about the first 9 records? So we don't have the data prior to 12th of July, so we cannot calculate the 10-day averages for them. So technically speaking, here we'll ignore them at a later stage. So we won't be considering the first 9 days at all for our analysis. So let me go ahead and run this piece of code. So we're going to use a for loop statement to do that. Again, if you look at the structure of a for loop, as we had discussed earlier, we first define the number of iterations and from where we start the iterations from. So here it is basically I is used to reference to a particular row ID or row number. In 10 is 2. So we start from the 10th row because ideally we don't have the data for the first 9 rows to calculate its corresponding 10-day average. So our first 10-day average would start from here until the end of the data set. So from 10 is to length of data 3. The 3 in this case, comma 3 is basically the third column. So here I will just explain how the notation is marked for a data frame. So here if I have to reference to a particular row, I would use the first part of the square indentations that I've marked here, and column is the second part. So if I'm referring to the third column and all the rows inside third column, I would mark it as data open square bracket comma 3. If I want to access all the columns inside the third row, for instance, I'll run this and show you here. So if I were to do this, I would get the third row and all of the columns inside of the third row. But if I did this, for instance, I'm getting basically all of the rows inside the third column. So 200.9023 is here, and these are row IDs, all of them inside the third column, which is close. Okay, so let me now run this block of code. And now we have a 10-day moving average that's created. So for 25th of July, it's 203.2108, and we have it till the end of the data frame. Now let's eliminate the rows that contain NAs. What we're doing here is we're eliminating the rows, the first 9 rows for which we don't have the moving averages. So we use the na.omit function to do that. And we have reassigned it back to data. So now data shows 243 observations instead of the earlier 252 observations, right? So that's the NAs that have been removed from it. Now we'll have to calculate the profits that were taken on a daily basis. So the rule again stated that Mark would enter a trade if and only if the opening price was greater than the moving average. And if that is the case, then we calculate the profit or loss for the day. Otherwise, if the trade was not taken, we mark the profits to be 0. Again, this is a for loop statement where we iterate through each row to see if the trade was taken or not using this condition. If it was taken, profits are calculated as a difference between close and the open price. If the trade was not taken, profits for that row is recorded as 0. It's again a simple for loop statement using if else. I'll run this loop now. So if you can see here, the profits column now indicate the differences between the close and open price. And now here it shows a negative number because if you see here, the open was higher than the mean price of 203. So it opened higher. So the rule is satisfied and the trader actually held, so Mark actually held the position until close, but it recorded a $4 loss for the day. And there were some days where the trade was not taken. So for instance, here the open was 205.53 as against 205.8868. So it's a lower open. So this would have resulted in a loss, but since the trade was not taken, profits still show you 0. And I'll show you one more record. So here, if you can see, the open price is higher than the mean price, 201 versus 200, and it closed higher for the day, $6 higher roughly, and that's recorded here. Now that we know the quantum of wins that were made and also whether wins were made in the first place or not, now let's calculate the streak of wins, because our question still requires us to calculate the streak of wins and the profit that was recorded for that particular streak. So in order to do that, we'll use another for loop. So here we're basically saying that we'll record wins to be 1 if the profits for the particular day was higher than 0. So if it is 0, then it's most probably that the trade was not taken. And if the profits are negative, it resulted in a loss. So we only consider wins to be 1 if profits are greater than 0. And this is now iterated through each and every row inside of the data frame. And we record wins to be a binary event, either 1 or 0. So I'll run this piece of code now and we can look at the results. So if you look at the results here, data dollar wins column. So most of the days it's 0. It's either 0 because the trade was not taken, like in this example, or it's 0 because it was a loss. And whenever there's a win, it's recorded as 1. So now that we know which days were wins and which days are losses, let's calculate the streak of wins or losses, right? So again, we'll use the for loop statement to do this. So in this case, if the wins are 0, we reset the counter back to 0. And if the wins are recorded as 1, then the counter increases by 1. So that's the logic. So I'll run this, and this is again a for loop statement. I'll run this piece of code. So if you can see here, on the 13th of August, we've recorded the cumulative sum also as 1. But on the 14th of August, it's reset back to 0 because there was no wins on that day. So the counter is not exactly cumulative sum. It's basically a cumulative sum if and only if the streak is established. So again, if you see here, it's 1 and 1 here, and then it's reset back to 0. Now we need to calculate for which series of days we had a cumulative sum show up instead of 1 here, show up 5. So that's our goal. So to do that, what we can do is we need to match 5 with any of the column items here. If they do that, then you have the 5-day period that you're looking at to calculate the streak. So the match function does that, exactly that. So what it does is it matches the number 5 with the cumulative sum here. So it shows you the index position. Now that index position is nothing but the row for the entire data frame. So what I mean by that is basically the first step is it will look for 5 inside of this column, and wherever it finds the first occurrence it will return a position. So this would be the first position, this would be the second. So what will happen is it will match 5 with any first occurrence of 5 in this column and return the row position 1, 2, 3 or whatever, right? So we have it until 243. So once it does that, it would then map it to data. Now data is actually a data frame. So I previously showed you that the first part of data before the comma gives you the row, and the one after the comma, it gives you the column. So here all of this is before the comma. So whatever position it returns, say for instance it returns 60, then 60 is data 60 comma. So it gives you the entire row. And row names would basically give you this particular name. So the first row is actually 10, not 1. So if it was the 60th row, it might probably be 50. No, sorry, it'll be 70, right? And so on. And then it gives you a numeric form of that. So as.numeric would be the numeric form of the row name. So let me run this code and I get 206. So 206 is basically the row name. So let me navigate to 206 first. And that's this one. Yep. So we have the first occurrence of 5. And there were 4 prior wins, and the cumulative sums also added up simultaneously. So the start date was on 29th of April 2020 and the end date was on 5th of May 2020. So to find the weeks taken, it took us exactly 41.2 weeks to achieve the 5-day winning streak. So now that we know the winning streak and when it was achieved, we need to calculate the profits that were made in that winning streak. So for this, basically what we're doing is we're again defining a for loop statement. So the for loop statement would do this. So we're again going to iterate through each of the rows in data. And if I is equal to 1, data $wins is also equal to 1. The reason why we're doing this is because there's no cumulative before the first one. So from the second entry onwards, we have cumulatives that we can do, but the first entry doesn't have a cumulative. So if I is equal to 1, this is if it's the first row, and if the wins is also 1, which means it's a win, then revised profits would exactly equal the profits that were made. So for instance, in our case, on the first day, it wasn't a win. So in this case, profits is actually negative, right? So this wouldn't affect our statement here. And if it's a loss, like our case, then profits would show, a new column would build showing revised profits to be 0, right? And if wins is registered as 1 and the previous one is also 1, then the profits would be a cumulative. It's similar to the cumulative sum that we found here. So if for instance this is a win, and we would have revised profits showing 0.5599. If the next day was also a win, then it would add the profit here with the profit here and then show a new revised profits here. But here obviously it's not a win, but if it were, then that's what the algorithm would do. So let me run this piece of code and then we can check our results. So I've run it now and I've got the revised profits table built out. So if you can see here, profits equal to the revised profits. On the next day, there's a loss and that's not recorded here. It's instead reset back. So it's similar to the cumulative sums that we discussed about, right? So this also is back to 0 and this is also back to 0. Now let's look at the quantum of profits that were made in the 5-day period. So we just have to run the same code again. Basically the first match of 5 with the cumulative sum. And we've already specified the column that we're looking at, so we don't have to use the comma anymore. We would use the comma if and only if we don't specify the dollar. So if you can see here, I've not specified dollar, but here I've specified dollar. So dollar already references the column. So we've already referenced the column. We've also referenced the row position now, and that should give us the revised profits. And that is saved as profits now, a numeric vector 12.204939. And we can go and check that also. Let's go to 206, row name. Here it is, 12.204939, exact match. So that completes our analysis. So as you can see, this was a very, very long route to solve the problem, right? So we were able to do something much shorter using the while loop. So as a developer, you will have to understand the problem statement and decide the correct loop to use. In a broad sense, for loops make sense when you know the exact number of iterations that are required. And a while loop is used for more exploratory, where you don't know how many iterations are required, and if you have to calculate odds of something. So for those kind of problem statements, while loops may make better sense. Again, I would leave this up to you, and you would also be able to decide which loops to use when over time with practice. Hey everyone, welcome back. So in this lecture, we'll be looking at the DPLYR package. As a first step, let's install it. So go to new file, R script, and type in install.packages, and DPLYR inside quotes. And yes. So I already have DPLYR installed on my system, but as I think updating it now to a newer version. And now let me call that using the library function. So library DPLYR, control enter. It's running. So wait for the stop symbol to vanish. Yeah, it's now loaded the tool. Cool. So now let's get started with the actual problem. So we're going to be loading the data set, the English Premier League data set. So we have all of the match day stats, right? So we have the 18-19 all matches played stats, and what we're going to do is we're going to actually build the points table based on the results, on the match day results. So download the Excel file that's attached with the lesson, and we'll import that into R to begin our analysis, right? So go to file, new file, and file, import dataset from Excel, and browse to where it's located, EPL. You'll get a preview. So it's date, home team, away team. HG is short for home goals, AG is short for away goals. Yeah, so import this, and there you go. You've imported the EPL dataset with 380 observations and 5 different columns variables. Yeah, so the first one is the date of the match, and the second and the third ones are the teams playing against each other. So here it's Man United versus Leicester, and Man United was home, Leicester away at Old Trafford, and Man U scored 2 goals and Leicester scored 1. So it's a victory to Man U, and so on. So we have all of the match day stats until the 12th of May 2019, right? So the rules of football are this, for EPL are this. The winner basically scores 3 points. If it's a match draw, then it's 1, and the loser gets no point, right? So it's either a win, draw, or lose. So let's get started with the problem. Right. So first step is we have all of these games that were played. Now we just need to find out how many teams are there. And for that, there's a function called unique that does that. So it basically looks only for the unique values in this column or in this column, and then it gives you that list. So for instance, we're going to look at teams underscore home, which is EPL $home team. EPL home team is basically this column, and it's going to look for unique of EPL $home team and order that, right? So if I run this code, it's going to give me teams underscore home and all of the 20 teams, right? It's a character vector. The reason why I've used order is it's basically alphabetical order, right? So if you look at the actual EPL points table, it's in its alphabetical order. Teams underscore away, same thing. We're going to sort them based on alphabetical order for now, and we're going to apply the unique function on it to get just the unique names. So on this particular column, it should be the same. So teams underscore home and teams underscore away should actually be the same thing, right? Yeah. And let's just check that it's true everywhere. Yeah. Good. So now that we know the teams that are on EPL, so we know the leftmost column, which is the team name, right? Right. So let's create a data frame with 9 columns and 20 rows, one for each team. So we have 20 teams, we have 20 rows, and we have basically 9 columns, and these columns are here. So basically, call names function gives you the names of the columns. So, and these are the different columns that we'll use: teams, matches played, wins, draws, lost, goals scored, goals conceded, goal difference, and finally points. Right? I'll run this, and that should create an empty data frame. There you go. Right? All of this is NA. Currently, it'll get populated with the values soon. Now, let's populate the first column with the team names, right? So points$teams, which is the first column, is going to be populated with teams underscore away or teams underscore home, doesn't matter. So we can basically use this or this. I'll populate it now. So now we'll basically build an algorithm that looks at each team in the points table and compares it to the home team and then the away team in EPL data frame. So once a match is found, then it checks if the which is greater, HG or AG, or if they're equal, and then decides the outcome of the match, right? So for example, let's take the second team in the points table, Bournemouth. Yeah. Now we'll check if Bournemouth is present in home team and away team. So one instant of Bournemouth occurs in the second row under home team, right? So if you look at the data set here, Bournemouth has actually played Cardiff at home and they won the match, right? So in this case, HG is greater than AG, so Bournemouth had won the match at home. So the algorithm will record 1 under win for Bournemouth. It will then look for other instances of Bournemouth lower down in the EPL data set and assign further values. So for now, we're building algorithms just to record wins, losses, and draws, right? So what it's actually doing is it's going to locate for instances of Bournemouth throughout the home team column as well as the away team column, and then it's going to look at the results. So for instance, if there's a match, so if there's a match in the home team, for instance, in this case, it will then basically compare HG and AG scores, right? So in this case, HG was greater than AG, so it's a win for Bournemouth, and that is recorded as a win. And the goals don't have an impact for now, but we'll be including it later, right? That's just a win for Bournemouth. And similarly, let's look for another instance of Bournemouth in the table. So here, for instance, right, in this particular case, it's going to scan the particular column and then see another entry of Bournemouth for home team and then look at the result. Both of them are equal, so it's going to record a draw, right? And so on and so forth. It's going to do this for each team. So just think for a second what we might use to do this, right? So we looked at different kinds of loops in the earlier lectures. So there's a while loop and then there's a for loop, right? A while loop is typically used when you don't know how many times you have to iterate, and a for loop is used when you exactly know how many times you have to iterate. In this particular case, we know that the total number of teams are just 20, right? So that's one. And second, we also know the size of the data set, right? In this case, EPL has 380 observations. So it's going to pick up one item from the teams underscore away vector, for instance, Arsenal. And then it's going to look at 380 observations, 380 rows, basically, and look for matches with Arsenal and then record the score. And then it's going to do the same thing for the away as well and record for Arsenal. So that's the process. It's very clearly defined and we know exactly how many iterations we need. So we'll use the for loop. Yeah. But in this case, it's slightly complex. We're not going to use one for loop, but actually two for loops, right? So one for loop would actually loop through the EPL data set, right? In this case, the EPL data set, and there'll be another for loop that will basically loop through the points data set. And why we need to do that is because it's going to look at points first, pick up the team name, and then use the EPL data frame to actually compare and match and find the row, and then look at the result and append it in the points table, right? So it's a two-step process. So in this case, okay, also we have assigned all NAs with 0, right? All of these are going to be numerics, right? Matches played, wins, draws, lost, goals scored, goals conceded, goal difference, points. All of these are numeric. So we're going to populate them with 0 for now, right? So for I in seq underscore along 1:n row of EPL, right? So we're going to loop through in the entire EPL dataset from the first to the last and assign it to I. For j in seq underscore along 1:n row of points, so j is going to loop through the 20 rows here. If points dollar teams j is equal to EPL dollar home team I, so it's going to look at the item here, and if that is equal to the item here, then it's going to look at the result. If EPL dollar HGI is greater than EPL dollar AGI, then it's a clear win to the home team, right? So points dollar wins J, points dollar wins J will show points dollar wins J plus 1. Remember, we set it initially to 0, and now it's going to be appended or increased by 1. Yeah. Else if EPL dollar HGI is equal to EPL dollar AGI, in this case that's a draw. So points dollar draws J, points dollar draws J is equal to points dollar draws J plus 1. And finally, points dollar lost J is points dollar lost J plus 1. So if it's not this, and if it's not this, then it's surely this. So that's the if else statement. Else if. This else if is for the broader example. This else if is compared to with this one, right? So for the first case, we looked at home team, and now we're looking at away team. So if the team matches in away, then it looks at, again, AG greater than HG. If that's the case, it will assign a win. If AG is equal to HG, then it will assign a draw, else lost. So this particular algorithm would match team names and then append draws, wins, and losses, right? So let me run this now. Yeah. And let's look at the points table, right? So if you look at it now, it's wins 21 for Arsenal, 7 draws, 10 lost. That's a total of 38 matches. All of them would play 38 matches. So that's the check that you will do. Basically, there's 19 other teams, and they would play 1 home and 1 away game. So that's going to be 19 into 2, 38 matches, right? For each team. Points dollar matches played is the sum of the 3. So basically, these are number of wins, number of draws, number of lost matches. So if I sum all the 3, I should get points dollar matches played. I'll run this now, and that should populate that column. So we are done with these 3 columns now, and we're still yet to do the other 4 of them. Right. Now, how do you find goals scored, goals conceded, and goal difference, right, using the for loop? So in this case, we looked at whether the match was a win or a loss by looking at the score. But now we'll actually account for the score, right? So we know that goals scored and goals conceded initially start at 0 for all teams. And then as the match progresses, as the league progresses, these numbers are going to change, right? They're going to increase every step, right? They're not going to decrease at all. They're all going to increase, right? So we know that information. So it's the same logic again. For I in SEQ underscore along 1:n through of EPL. So we're going to loop through EPL. And then we're going to loop through the points table here. And we're going to find a match between teams J and EPL $home team I. So if it's a home match, for instance, in this case, EPL $HGI plus points $goal scored J, right? So in this case, it's going to be HGI, which is 2, plus the points $goal scored. So we're adding whatever the value it shows in this column, right? And points $goals conceded J is EPL $AGI plus points $goals conceded. So we know that we start both at 0, and a team, so in this case, let's take the first example. So it's going to look for Man United, and it's going to match it with the home team here, and then it's going to add 2 goals to goals scored and 1 goal to goals conceded, right? And it's going to do the exact reverse for Leicester, right? So else if points $teams J is equal to EPL $away team, then it's going to do the same thing in reverse for the other team, right? So let me run this for loop now, and let's check the points table. And there you go, 73 goals scored by Arsenal for this season, and they conceded 51 goals, and so on, right? And we have it for all the teams in the EPL. Points $goal difference is the difference between goals scored and goals conceded, right? It's a straightforward formula. So let's do that, and let's check again. And there you go. So goal difference is 22 for Arsenal. A positive actually means that they've scored more than they've conceded. Bournemouth has conceded a lot of goals. That's 56 minus 70 minus 14, and so on, right? Now let's calculate the points. So we're going to assign 3 points to wins, 1 point to draw, and there's no point to lost, so I've not included it in the formula. Yeah. So let's just check this again. And we have the points for all the different teams, right? Right. So another unique feature of dplyr is this particular function. So this leverages code readability. So you don't have to write multiple lines. You could just pass on outputs as an input to the next one and the next stage and so on. That makes it very convenient to reduce the number of lines of code. And I'll show you how it's used in the later lines here. And mutate creates a calculated field. So mutate is one of the other features in DPLYR that helps you create a calculated field. Okay, so let's look at filtering out only Arsenal from the points table, right? And see if we've used a sign here. So filter is a function that comes with DPLYR. So it's going to filter teams equal to Arsenal, and then it's going to pass that to points, right? If I do this, I should just get Arsenal. Here, mutate is used to create a calculated field. In this case, it's rank. So we need to rank teams based on the points scored for the season. So let's do that now. Points is points of mutate rank descending points, right? So let me just run this line of code. I'll show you what's exactly the case here, right? So it's going to be sorting teams in descending order, which means that the team with the highest number of points is ranked number 1 and so on. So in this case, for 2018-19 season, Man City is rank 1, followed by Liverpool and Chelsea and Tottenham, and the others are after that. So ranking of teams is usually based on 2 levels. One is based on points, and in case of a tie, the team with the higher goal difference gains a higher rank, and vice versa, right? So let's filter our data set for ties first and then save the output as a vector, right? So here the summarize function is summing the number of occurrences of duplicated ranks. So I'll just run this line of code. Yeah. So what's happening here is it's basically grouping by rank, right? So we have all of these ranks here. And then it's filtering for occurrences greater than 1 and then summarizing them. So typically you wouldn't be able to group it by rank unless there's a repeat, right? For instance, Leicester is 9.5 and it is shared with West Ham, right? Also 9.5. Similarly, there's Bournemouth at 13.5 along with Newcastle. So these two would be grouped and filtered out, right? So duplicate ranks are 2 and 2. Now let's rearrange teams based on ranking from first to last, right? Okay, so the bottom 3 teams in the league table are relegated each year. So let's find out which ones they are, right? So the reason why we've used slice_max is because we have classified the best performing teams as rank 1. So the bottom three teams would be rank 18, 19, and 20. So we've used max here and we're slicing it out. Slicing does exactly what the word says. It slices out rows that you don't need. And in this case, it's going to be, since we have ranked them in increasing order, in this case, it's a decreasing order. So we have ranked teams in terms of rank 1 is the best team and rank 20 is the worst team in the league, right? So based on that ranking, it's going to eliminate the last 3 rows and assign it to bottom_3. So the teams are Huddersfield, Fulham, and Cardiff, right? The ranks 20, 19, and 18. And the top 4 teams is going to be now just the reverse slice, right? Slice_max was for the relegated teams, and for the ones that would qualify for the Champions League, slice_min. And there would be 4 teams, right? And they are the top 4: Man City, Liverpool, Chelsea, and Tottenham. Now let's try to find out the average goal scored by each of the top 4 teams, right? So we're going to group by teams. So in this case, we're going to have 4 entries, and then we're going to summarize mean is equal to goals scored by matches played, right? So There you go. Chelsea has the highest number of mean goals scored per game. Not Chelsea. I'm correcting myself. It's Man City at 2.5, followed by Liverpool. Then Chelsea and Tottenham are close, right? And that makes sense, right? So Man City won the league only because they scored a lot of goals, right? So this completes the exercise, and hope you guys enjoyed this particular lecture. That's it, guys. See you in the next one. Hey everyone, welcome back. So in this video, we'll be looking at some of the graphing capabilities in R, specifically using the ggplot2 package. So if you don't have it installed on the system, you have to install it now using the install.packages function. Just key in ggplot2 inside of quotes and hit enter, control enter, and it should install. This may take a while. For me, it's already installed, so it didn't take much time, but it may take time to install all of the dependencies and so on. And then use the library function to call the package inside R. And now go ahead and download the air quality CSV file with the lesson and import it into R using the read.csv function. You've not done this before. Basically, what you'll do here is you'll have to set the directory first. And for that, you just go to session, set working directory, choose directory, and set it to where you've downloaded the file to, and then run this line of code. So here I've installed, I've downloaded air quality, and I've loaded it up here and saved it as data. So here we have 6 parameters, 6 variables, and different measures for ozone, for solar, for wind, for temperature, month, and day. So now let's create a scatter plot. And for that, we'll need to call the ggplot2 function. Data is referring to this data where we have saved all of the values. AES is short for aesthetics, and the first one here is specifically for x-axis. In this case, we are plotting day in the x-axis, day of the month in the x-axis, and temperature in the y. So that's here, temperature. Group is equal to month, so we're grouping by month. I think we have 5 different, we have 1, 2, 3, 4, 5 different months, 5, 6, 7, 8, and 9. So we're grouping them by month. So each month would have a particular color using the color factor. Then geom underscore line would ensure there's a line graph plotted. Scale underscore color underscore veridicity is the color palette that would be used to generate the different colors for the months. Labs is the labeling for the x and y axis. So x axis is day of month and y axis is temperature in Fahrenheit. Team underscore BW is basically going to convert the plot into a plain white background without any of the grid lines. And all of these are aesthetics inside of the plot. I'll show this as I run the code first. So let me first run this code and generate the plot. So there you go. So if you can see here, we have the temperature versus day of month title showing up on the top panel. And then we have the X and Y axis and also the legend here with the color codes for different months. So if you can see here, we have configured all of this positioning and colors here. Legend.position equal to right. It's on the right side of the chart. Plot.title is color black, size 12, and face equal to bold. So it's a bold black color on top. Legend.background is light blue, and this is for the background for the legend. Similarly, panel border and panel grid. So we have considered the grids as black. And finally, for color, we have a title, which is months. And the GG title is the title for the plot, temperature versus day of month. Thanks for watching. Do leave a review if you liked the course.